So let us continue with now another session on the presentation of rainfall data. So once you have a catchment, you have collected different rainfall data. Now it is time to present those data. You have just the rainfall depth, you have just the respective time. So generally, this is a general presentation, of rainfall records against time. Generally, when we talk about the presentation of rainfall data, we mean this. So there are different methods which are used to present rainfall data. So there are so many methods, but in this session, let's talk about like 3 methods which are commonly used in the presentation of rainfall data. So 3 methods generally. So the first one that we are going to talk about is the Hyetograph method. Hyetograph method. This is one of the methods which are commonly used to present rainfall data. The other one, which is mostly used, is the mass curve of rainfall method. So that is another method which is commonly used to present the rainfall data, and the other method is the point rainfall method. Mainly, these are 3 common methods which are used to present rainfall data. So now it's time to go through every method to better understand how each method works. Let us understand it. So let's start with Hyetograph. So when you talk about Hyetograph, Hyeto means just rainfall. It's like a rainfall or precipitation. A graph, it's a plot, a graphic representation, a plotting something. So we are plotting the rainfall. So what is this? We can say that a hyetograph is a method of representing the relationship between the rainfall intensity or precipitation intensity and the time. So in that case, if you plot that relationship, this kind of plot or this kind of graphic representation is the one called hyetograph. So it is can be defined as it is a graphical representation of the relationship between rainfall intensity and or against time. So these are the most important point to be focused when we talk about the hyetograph. So mainly it is a hyetograph is a method or a graphic representation of the relationship between rainfall intensity and the time. So meaning what? If you remember, the rainfall intensity is what is written maybe as I, which is the precipitation depth over time, and the time, you know it. So if you want to plot a hyetograph, it looks like this. Let's take an example. This is an example of a hyetograph. Assume that we have the rainfall intensity, let's put it maybe in millimeter. Sometimes it is millimeter per hour or centimeter per hour. And put the time maybe in hour. If you wanted to show a given relationship, assume that here we have maybe 0, here we have maybe 0.5, maybe here we have 1, 1.5, here we have a 2, and we want to show maybe the relation, what was maybe the relation between rainfall intensity and time in a given catchment. Assume that in the first half hour, maybe in the first 30 minutes or 0.5 hour, the rainfall, let's say, intensity was maybe, let's say, 1, here maybe 2, 3, 4, something like that. In the first period was like this. In the second one maybe was like this. This is an example. In the third was like this, and in the fourth it was like this. This is an example. This is an example of a hyetograph. It is a graphic representation of the relationship between rainfall intensity and the time. So if you have a given catchment, let's take a catchment, and it is raining during maybe 2 hours. It is raining during 2 hours in this catchment. You can plot the relationship between the rainfall intensity, how much water is the catchment receiving per unit of time during a given duration of that rainfall. So the rainfall intensity against the time is the one called hyetograph. So this is like a bar graph. This is like a bar graph. If you want, you can say that a hyetograph is a bar graph. Bar graph is a bar graph. So which shows the relationship between the rainfall intensity and time. So meaning what? Here it means between the first 30 minutes, if you say 0.5 hour is the same as 30 minutes. So in the first 30 minutes, it means that the rainfall intensity in this period, the rainfall intensity was 1 millimeter per hour. That was just the rainfall intensity in the first 30 minutes. So between the 0.5 hour and the first hour, the rainfall intensity was this much. This is 4 millimeter per hour, and so on. So this is a representation of rainfall intensity against the time. So mainly this diagram or this graph is helpful in presenting, if we want to present maybe the characteristics of a storm. So characteristic of a storm. Of a given storm. This is a good presentation of the characteristics of a storm. If you have a hyetograph like this, it's a good way of presenting the characteristics of a storm. And it helps us where this hyetograph also is helpful, is useful in calculating or in determining in the design storm for predicting floods. So if you want to predict the floods, this graph can be helpful because it can help you just to determine the design storm. That is another important of this hyetograph. So mainly that's what we were saying. So hyetographs are used in various ways. One of the ways is just to represent the relationship between rainfall intensity and the time, but also it can be used just to determine or to develop, if you want to develop the design storm for predicting floods or extreme floods, if you want. So if you want to predict extreme floods, this hyetograph is also useful. Remember that the area under hyetograph provides the total rainfall received by an area in a given period. So meaning what? The area of this, the area of this, the area of this, if you sum up this area, you get the total rainfall received by a given catchment in a given period. So area, you can say that the area of or under hyetograph graph gives the total rainfall received by an area, or a catchment or basin in a given period. So generally that's how we can say. So the area of this graph, once you find the area of this graph, you get the total rainfall received by that catchment in a given period. So mainly that's what we can say. So here we have an example of a hyetograph. Then we are asked to find out the total rainfall depth received by this area. So this is the y-axis. On the y-axis we have the rainfall intensity in centimeter per hour, and on the x-axis we have the time in hours. So I have told you that if you wanted to determine the total rainfall depth, it's a matter of computing the whole area under the hyetograph. So this is area 1. You can say this is area 1, this is area 2, area 3, area 4. Meaning what? The total rainfall depth, total rainfall for depth will be equal to the sum area, total area under the hyetograph. So it's a matter of computing each area and summing up, meaning that area 1 plus area 2, area 3, area 4. So this is the hyetograph which indicates the variation in rainfall intensity against time of a given storm. Then we are asked to find out what? To find out the total rainfall depth. So area 1, if you want to compute the area, it means that the first portion is between 0 to 8. Meaning what? You have this side and this side. It's a matter of taking this multiplied by this. So area 1, it's like taking the rainfall intensity, which is 0.3 what? Centimeter per hour, times what? Times the 8 hours. So hours cancel each other, you get 0.3 times 8. 0.3 times 8, you get 2.4 centimeter of rainfall. So area 2, if you want to compute area 2. So the area 2, you take 0.2, that is the rainfall intensity, times the time in between it. The change in time, here the change in time is 16 minus 8, meaning what? Times 16 times minus 8. So which means it is 0.2. 0.2 times what? Times 8. 1.6 centimeter. Area 3 is what? It's area 3, it's up to here. 0.4 is the rainfall intensity times what? The change in time. 24 minus 16. 24 minus 16. We get what? We get, this is also 8. 8 times 0.4. We get 3.2 centimeter. And the last one is just 32 minus 24, and the rainfall intensity is 0.1 times what? 8. 32 minus 24. We get what? 0.1 times what? Times 8. We get 0.8. So the sum, total rainfall depth, the total rainfall, T total, or total rainfall will be equal to the summation of this, meaning 2.4 plus 1.6 plus 3.2 plus 0.8. The total rainfall will be equal to what? Will be equal to 2.4 plus 1.6 plus 3.2 plus 0.8, which is equal to 8 centimeters. So this is the total rainfall. This is the total rainfall received by this area in this time during 32. The storm duration, the storm duration is 32 hours, and the rainfall, the total rainfall depth was 8 centimeters. Generally, that's how we can use the hyetograph. So let us continue with the second method of presenting the rainfall data. So rainfall data, the second method, we have said that it is called the mass curve of rainfall. Mass curve, a mass curve. So a mass curve is a plot of cumulative rainfall against time, but in a chronological order. So meaning what? So it is a plot of, so let's call it, this is mass curve. Mass curve, it's a plot of cumulative rainfall. Rainfall for depth versus time, and the time in a chronological order. So mainly this is the relationship between the cumulative rainfall and the time. This is the time. So this graph is for time. So in a chronological order, meaning what? If today it is 20th July 2021, and on this day maybe the rainfall was this much, was let's say 12 centimeter, and on 21st, maybe on 21st July it was maybe 15 centimeters, the rainfall, and on 22nd July it was, let's say, 80 centimeters. What we call chronological order. So you start from this and you continue this way, chronological order. So this is the chronological order. So meaning that the mass curve, it is a graphical representation of cumulative rainfall against time in a chronological order, starting with the old, if I can say, the old period or the old date to the current, to the new date, to the current date. Meaning what? So how do we plot this? So let's see now how do we plot this. You see that the cumulative rainfall, cumulative, meaning what? If, let's say on one day, let's take one day. We are today, it is raining, we are receiving a storm. When we are receiving a storm, it is maybe continuing during maybe more than 24 hours. So in the first 4 hours, what was the rainfall? Something like that. So if we try to plot, the rainfall was around 2. So maybe in the first 4 hours, the rainfall was 2 centimeters. And in the second, maybe we got, let's say, 4 or 3 centimeters. In the third hour, we got, let's say, 5 centimeters. So in the first hour, this is an example. In the first hour, we received this. In the second hour, we received 33 centimeters. In the third hour, we received 5 centimeters. So what do we mean the cumulative? It's summing up, which means we can start like this. Secondly, we start the cumulative, this plus this is 5. When we reach this point, we take this plus this, meaning what? 5, 10. This is what we call cumulative rainfall. Cumulative, you sum up. You take the previous depth, you summing up with the current rainfall to get a new value and so on. So it's like a summation. When you do cumulative rainfall, is just a sum. Sum of just different values. You take what you have got, the previous values, previous value plus the current value, and so on, and so on. If you want the cumulative rainfall. Let's take another example to better understand. So let's use this example. Let's use this table to better understand what is the cumulative rainfall. So here we have days, day 1, day 2, day 3, day 4, day 5, day 6. Assume that on the first day we received this rainfall. Assume that the rainfall in millimeter, so and so on. If we want to calculate the cumulative rainfall, at the beginning you write the first number you have. The rainfall on the first day was 5, so you take the number as it was when you start. So for this second one, if you want to know the cumulative rainfall on day 2, you take this plus this. This plus this means if you take this plus this, you get 7. So this plus this, you get 7. 7 plus 0 is 7. This plus this, you get 10. 7 plus 3 is 10. 10 plus 4, it is 14. 14 plus 1, it is 15. So this is what we call cumulative rain. So you take what you get, the previous value plus the current, to get the total rain. So this is how we compute. The cumulative rainfall. These values are called cumulative rainfall. You take just the previous plus the current to get the total rainfall, cumulative rainfall. So in the same example, so here we have a curve showing what happened in a given catchment. In a given catchment, these are the hours, meaning that from 0 to, this is the first day up to here, day 1. Day 1. This is what happened on day 1. So on day 2, let's maybe start from here. On day 2, this is day 2, up to 20 hours, day 2. Day 2, this is day 1, day 2. This is how the rainfall was received in this catchment. So in the first 4 hours, there was this. After 80 hours, the cumulative was this. After 12 hours, the cumulative was this, and so on. The cumulative rainfall. So when you sum up the previous with the current, this is the graphic representation of this. So mainly what we can say, the mass curve is plot by using a rising curve. So you see this curve is rising at a positive slope, something like that. And the slope of a mass curve provides the rainfall intensity. Slope of a mass curve provide the rainfall intensity in that period. Rainfall intensity. So that is another thing to highlight. The slope of a mass curve. If you want to find out the slope of this portion, the slope, of course, if you remember the slope, if you take the vertical divided by the rise divided by this horizontal distance, you get the slope. The slope of this, you get the slope of this portion in this period. So you see, so if you want maybe the rainfall intensity in this period, you can also just find out. This is change in time, change in the precipitation. So once you get this over this, you get the rainfall intensity. Rainfall intensity will be equal to this and so on. So in this where we have just a horizontal line, it means there was no rainfall. This no rainfall, no rain. It means the rain was 0 in this when it is horizontal. So when we have a horizontal means that there was no rainfall. So here there was no rain, or the rain was 0 in this. When the horizontal portion of a mass curve indicates that there was no rain. So horizontal portion of a mass curve indicates that there was no rain. Or in other words, the rain was 0. So here the rain was 0. This is how we can just use the mass curve to indicate the cumulative rain against the time. So in our example, we can say that we have 3 storms. So the first rising curve up to here represents the first storm, while the second rising curve up to here represents the second storm, and while the third rising curve represents the third storm. Like we have 3 storms where it was raining and stopping, again raining a bit and stopping, raining and stopping. So that's how we can present that scenario where it is raining and sometimes it is stopping, and it is again raining and stopping, and so on. This is how we can present that scenario. So to get the first storm or the depth of that storm, it's a matter of taking the starting point was 0 up to the stopping point. If you come here, it is somehow 4, meaning that this portion, to get the depth of this portion, you take 4 minus 0, which is a 4, which means the first storm depth was 4 centimeters. This is it. Here it is 0. I told you the horizontal portion of a mass curve represents no rainfall, meaning there is no rainfall. And the second storm started from 4, from here to up to somewhere here. So if you continue this way, it was somewhere here, nearly. So it was, it's like 7.6 minus 4. 7.6 minus 4. Then you get what? If you take 7.6 minus 4, you get 3.6. So the second storm was from here to here, which is equal to 3.6 centimeter. And the third storm is this one. The third storm is this one, and it was from 7.6 up to nearly, this F is nearly, when you continue, is nearly to 10.2. So it was ranging from 7.6 to here. So this is the third storm. So taking this minus this, you get 10.2 minus 7.6. 10.2 minus 7.6, you get 2.6. So this is the third storm depth. Mainly, this is how we can present the mass curve. Mass curve is a plot of cumulative rainfall against time, and it is a rising curve. Where it is rising, it shows a storm. Where it is in horizontal, it shows there was no rainfall, and the slope of that curve provides the rainfall intensity. If you take this distance over this, you get the rainfall intensity during that period, meaning between the 16th hour to the next 4 hours of the next day, you can get what was the rainfall intensity, and in between from here to here, you can get the rainfall intensity in this period, and you can get as well the rainfall intensity if you calculated the slope of this. So mainly, that's how we can plot the mass curve. Let us now continue to the other method. But before continuing to the other method, let's say that also the automatic rain gauges, automatic rain gauge records are of this type as well. So the automatic rain gauge also records, the records looks also like this. The automatic rain gauge, when they are recording, the records also looks like a mass curve. This is what we can say about this. So here is another example of methods used to present rainfall data. This method mainly is the other method which is used to present rainfall data. It is called the point rainfall method. How does this method work? It is the simplest method compared to other two methods. It is also called the station rainfall. So if you have a catchment like this, you have a rain gauge, maybe let's call H. This is maybe one of maybe towns in Rwanda, Kigali, and we have a rain gauge there. It is measuring the rainfall each month. So and you want maybe from January to December, it has recorded given rainfall. So the point rainfall which have been measured at this station can be presented or plotted in a graph, in a form of a graph. So plot of rainfall depth versus time. This is the one called point rainfall method. So we plot the rainfall depth against time. You see, we have rainfall depth in millimeter, and we have our time in a month. So if you want, this plot can be weekly, daily. The time can be daily or can be weekly, can be seasonally, can be maybe monthly or annually, it depends. You can just use this type of graph or plot to show the rainfall, how it is varying from month to month or from year to year. So this kind of presentation is the one called the point rainfall method. It is a simple method which can be used. You see this in an example. It means that in January the rainfall was nearly 50 something millimeter, and in February it was this value, in March it was this value, in April it was this value. So we use like a bar graph, what we call bar graph. This is a bar graph. It is mainly used to present the point rainfall method. So assume that we have also maybe different years. Let's say maybe we have a year and we have the rain recorded maybe in centimeter. So we have maybe year 2010, 2011, 2012, 2013. Here we have, let's say maybe 100, 120, 80, and here we have maybe 95 centimeters. If you want, you can present these data using what we call point rainfall methods. It's a matter of doing this. Rainfall depth in centimeter, and you have the time, or in year. This is the year. So you have the first year is 2010. The rainfall was 100. Let's put maybe we have 100, 120. Let's put maybe let's say maybe, if you want, maybe 30, 60, 90, 120, and so on. So the first month in the first year 2010, the rainfall was 100. 100 is around here. In 2011, the rainfall was 120. Let's put it maybe here. And 2012, the rainfall was 80. 80 is somewhere here. In 2013, the rainfall was 95, nearly here. So this is a graphical representation of what we call rainfall data against time in using point rainfall method. You see, this is the easiest method which can be used. So using a bar diagram or bar graph. So it can be used for presenting daily data, weekly data, seasonal data, monthly data, or annual data, or decades data, something like that, of a given place. You see that this method is somehow easy. This method is generally easy. If you want to use it, the method is easy. So to remind you that this method can also be used if you wanted to find out or to plot the IDF curves. If you want to draw IDF curve, intensity, duration, frequency curve, this is helpful when you want to draw this relation as well. This is helpful if you want to find this relation. So that is the end of this video. Remember to subscribe to this channel and watch other previous video that we have made on estimation of average rainfall or estimation of missing rainfall, and other videos on hydrological cycle component, the explanations. You can just visit this channel to better understand each component, how it was explained. Thank you.